Okay, so we are looking at page 59 in the student journal. All right, now here's the nice thing about Honors Algebra 2. We want you to do things the easiest way. I'm never going to tell you you have to do this problem by completing the square, or you have to do this problem by factoring. You should do it the easiest way that it is to do it. So on these problems it says determine whether you would use factoring, square roots, or completing the square to solve the equation. Explain your reasoning. I'm not going to make you explain your reasoning, but I do want you to solve the equation. Looking at the first problem, I could complete the square by taking half of 7, getting 7 halves, adding 49 over 4 to both sides. But that's the hard way to do this problem. I can factor this by, whenever I have two terms, I just want to look for a greatest common factor. What can I factor out of those two? Just an x, right? So if I take out an x squared divided by x is x, plus, what's 7x divided by x? 7. And I have to make sure it equals 0. If it equals anything else, it's not a helpful method. But because it equals 0, I know if two numbers multiply to be 0, either the first number must be 0 or the second number must be 0. So my solution is 0 or negative 7. All right, I want you guys to think about number 15. You could multiply this whole thing out, bring over the 35, but what's the easier way to do this one? Just do what to both sides? Square root it. So go ahead and do that on your own. Check your answer up here. All right. Questions? What about number 16? What are you going to do? Yeah, Kerrigan? Yep. And this is one of those perfect squares that I hope you have memorized. You might know the square root of 225? 15, good. So it's going to just be plus or minus 15. Mine got kind of cut off, so I had to rewrite it. What would we do on this one first? Divide by 4. I would just divide by 4. If it's an equation, you're allowed to divide through by any number. Can't divide through by a variable, but you can divide through by a number. So we're dividing through by a constant of 4. Now I should stop and check to see if it can be factored. Are there numbers that multiply to be 3 and add to be 2? Multiply to be 3 would be what? 3 and 1, but do they add to be 2? No, they would only subtract to be 2. So if this had been a minus, we could factor it. But because it's a plus, we can't factor it. So what would we have to use? Completing the square. So we're going to have x squared plus 2x. We take over the 3. I take half of this and square it. I'm going to add 1. What's another name for this right here going to be? X plus 1 squared equals negative 2. Take the square root of both sides. And I get x plus 1 equals, and this is going to be plus or minus, and what do I have to take out? I. So I'm going to have I radical 2. And so now I just have to take my 1 over. So is the 1 positive or negative? So negative 1 plus or minus I radical 2. What does that tell me about this function? Does this function ever equal 0? Nope, it doesn't. All right, number 18 says the area of the triangle is 30. Find the value of x. What do we do on triangles? How are we going to work with this? What do you think, Luke? Equals what? Good job. See what he's doing here? Base times height, or height times base in this case, divided by 2 is 30. So now do you know how to finish the problem? Here again? Right. So I'm going to have to multiply both sides by 2. These cancel. I'm going to get 3x times x plus 2 equals 60. Can I just set 3x equal to 60 and x plus 2 equal to 60? Nope. Have to distribute 3x squared plus 6x equals 60. I can divide through by 3. X squared plus 2x equals 30. 20. I meant that 20. Thank you. I can think of taking this over. Are there numbers that multiply to be 20 and subtract to be 2? Numbers multiply to be 20. I could use 2, 10, 4, 5. They don't multiply to be 20 and subtract to be 2, though, do they? So we're just going to have to complete the square. So we're going to have to take half of this and square it is 1, add it to both sides. So we're going to get x plus 1 squared is 21. Square root it. X plus 1 equals plus or minus radical 21. And so here's what x equals. Now, both of those, though, are not our solution for x. One of those is not a solution. See, this is two solutions. It's negative 1 plus radical 21, and it's negative 1 minus radical 21. Anyone know why one of those is not our solution?
Because you can't have like a negative area.
Right. If I had x being negative, I'd end up with a negative area. That doesn't work, does it? So we're going to have to use the x value of negative 1 plus radical 21. Does everyone agree that that's a positive number? Yeah, because look at this, guys. If I want to know what radical 21 is, I know radical 16 is 4. Radical 25 is 5. So what's radical 21 going to be? About 4.5, 4.6. So negative 1 plus 4.6, that's a positive number, so we got it. Okay? All right, we have 2 more. Number 19 is very important. So I want you to make sure that they only give us one of these examples, and this is something that's going to come up over and over again. So make sure you watch closely. What we want to do is we want to get this into vertex form. Let me remind you of what vertex form is. It's y equals a times x minus h squared plus k. Okay, so that's the form I'm trying to get it in. Luckily, my a is 1, so I'm not going to have to be too worried about that. So now I'm going to have y equals x squared plus 6x. Now, I'm just going to move this 22 over a little bit because I want to get it out of the way. Because to put it into vertex form, I'm not going to have to worry about the a because it's 1, but I have to have some quantity squared. And this doesn't go down to some quantity squared. So to complete the square, I have to think, what's half of 6 squared? What am I going to put? Plus 9. But if I add 9 to this side, I'm also going to have to subtract 9 to this side. See, look, I added 9 to this side, but I'm also going to subtract 9 from this side. Do you see how if I do that, it's really just x squared plus 6x plus 22, like it's supposed to be? I can't change the meaning of this. Like if I would have put plus 9 here and plus 9 here, I would have actually added on 18. I'm not allowed to do that. I have to keep it equivalent. So this is the way it should look. Now I'm going to work with these 3 and these 2. So how does this factor? Right here, just this.
X equals 3 squared.
And then what's 22 minus 9? And so now I'm in vertex form. So what is the vertex? So that is the vertex. So let's say we're taking a quiz. We're supposed to find the vertex. We tried doing it this way, but then we feel like, I'm not sure I did that right. Let's say it's non-calculator. How could I find the vertex of this without using a calculator? Yeah, Luke.
Did you plug the negative 3 into x, 13 into y, and see if it equals 2?
Yeah, you could do that. That's a good idea. He's saying put 13 in for y, put -3 in for x, and see if it equals. That's a good way to check. What's another
You
way?
do negative b over 2a, and
Yep.
then plug that in.
Yep, that's how we find the vertex too, right? Negative b over 2a, f of negative b over 2a. So watch, I'm going to do this kind of quick. -6 over 2. What's -6 over 2, guys? -3. Plug in -3. -3 squared is 9. That's -18 plus 22. That's -9 plus 22. -9 plus 22 is 13. See how we get the same answer? I like doing it this way, though, completing the square. I think it goes pretty quick and it makes sense. Once you've done it a couple times. The first time you see that, it's kind of confusing, but then you get the hang of it. All right. A golfer hits a golf ball on the fairway with an initial velocity of 80 feet per second. The height h in feet of the golf ball t seconds after it is hit can be modeled by the function h of t equals -16t squared plus 80t plus 0.1. Find the maximum height of the ball. What do you think? Let's say it's on the graphing calculator part. Kerrigan? Okay, she's right. Let's go to our calculator. Let's go to y equals. And by the way, which way is this going to open? Up or down? Down. So we know it will have a max. So I'm going to do a zoom 6. Uh-oh. I can't see the max, can I? So I'm going to have to change my window a little bit. The X's are fine, but I'm actually going to go in a little closer. Maybe like this. The Y's, though, needed to be quite a bit higher. I'm going to make them 100, see what happens. Yeah, it's pretty good. Might go a little bit higher still. All right, I like that. Everybody understand what my thinking was there? Just trying to get high enough to see the max? So now I'm going to do second trace, calculate, maximum is number 4. I have to be right to the left side of it. So I'm on the left side of it. I hit enter. And now I have to go to the right side of it. Hit enter. Hit enter one more time. And there it is. Remember, the calculator's not great at this because it's trying to count pixels. So it's exactly 2.5 and 100. It could be 100.1 actually. Let me see something. Calculate a value when x is 25. Oh, it was 2.5, wasn't it? Oh, it is 100.1. Okay, I'm glad I checked that. So the maximum height of the ball is 100.1 feet. Okay, what about how long it takes the ball to hit the ground? What do I want the height to be, or what is the height when it hits the ground? 0. So what I can do now is go under y equals, put y sub 2, make it what? 0. Okay, I might want to make my window, my y's a little lower, just because I want to be able to see that better. All right, so that's good. I can see that y equals 0 real well. So now I want to do second, calculate, intersect. Got to get over there close or it's going to find the wrong one. That's close enough. Enter, enter, enter. 5 seconds. We're going to round to the nearest hundredth, so 5 seconds.
Couldn't you just double the x from the vertex?
You could. Now, the only reason you have to be a little careful with that is because this didn't start at 0. It started up a tiny bit higher. Okay? If it's a perfect parabola with a vertex of 0, 0, you can always do that. But what you have to be careful about is what if we've been throwing the ball like a football player from a height of like, 6 feet? Then the parabola might look like that, and it wouldn't work in that case, but it would in this one because it's so close to starting at 0. All right, makes sense? Just one more quick thing I want to show you guys, and that is if we have a coefficient in the top. Let me just do one more example for you here. I'm going to do a really tough problem. If you have some space right here. So let's say we've got 2x squared plus 3x minus 5 equals 0. And I'm trying to solve this. It can't be factored, so I'm going to use completing the square. So I do 2x squared plus 3x. I'm going to take this 5 over. Here's what I want to point out, is that the coefficient of x squared must be a 1. It has to be a 1. So in order to do this problem, what do I have to do before I can start completing the square? Divide by 2. So in that case, I'd get x squared plus 3 halves x equals 5 halves. And you would just have to work with these fractions. What is half of 3 halves?
3/4.
3/4. And what is 3/4 squared? 9/16. So see how this is going to get tougher? But what's this going to factor into? X plus square root of this, what is it? 3/4, right? This I have to get a common denominator, so I multiply by 8. And I get 49/16. That means it actually could have been factored because that's going to come out even. Anyway, take the square root. X plus 4 has to equal 7/4 plus or minus. And then you can finish it from there, right? Just wanted to point out that anytime this number, even if it's going to make this be like a hard fraction to work with, you have to divide through by that x squared coefficient. Okay? All right, good job, guys. So you've got your assignment up there on the board. It's also on Canvas.